what is exciting is that we've developed a new kind of method to move air. It's called the dual piezo cooling jet. It's an air mover that doesn't require bearings or doesn't require a DC motor. So we are enabling the next generation of tin products with this new technology that comes out of our labs.
We basically copied nature. Dual cool jets are really based on the idea of your lungs. They basically contract and expand. As that happens, the air is sucked in through your nose and out through your mouth. So we copied that to create a synthetic jet. We thought about, is there any way that we can actually create these jets in situ wherever we want to do that? Mainly was active flow control for aerofoils for different parts of the aircraft and engine.
A dual piezo cooling jet is two metal discs with piezo elements on either side of it. By actuating the piezo with an AC signal, the device can actually pump like a bellows pump. When you do that at a very high rate, say a couple hundred hertz, you get a very nice net airflow produced by this device by pulling in the air from the surroundings, expelling it at high velocity through the center. And there are different tricks you can do to make them smaller, larger, but the particular concept can be scaled or modified to whatever your application needs are.
Here we have an aviation chassis with 6 dual-cooled jets mounted to the frame. We have now switched to a thermal infrared image. We're heating the chassis to 80°, and we're going to drop that temperature down to around 40°. When each dual-cooled jet is turned on, air flows from the orifice and will blow up through the fins to the surrounding air, thus cooling the internal electronics of the chassis.
As engineers, we like to try new things, so we actually bought a state-of-the-art ultrabook laptop, opened it up, and replaced the fan inside this device with the dual piezo cooling jet. Actually, it was a perfect fit. There was, in the XY dimension, a lot of space available to put the jet in. In the Z dimension, we actually had a lot of space left over. Because the dual cool jet is such a thin solution, there's a lot of space left over that allows this laptop to become thinner if necessary, or that space could be taken up with other electronics. This is the first laptop in the world that's cooled by a dual piezo cooling jet.
Thin is the new fast. Increasingly today, manufacturers are looking to differentiate their products based on the form factor and how their customers are using the computing versus how much computing power is built into the product. It's a theme towards more power in smaller spaces. We can put these dual piezo cooling jets into a lot of very hard to reach places, so it's a very localized and very efficient way to cool electronics at the source of the heat generation. For people who have a laptop computer in their hands or on their lap, they don't want to deal with annoying noises or buzzing. So the acoustic profile of this technology, it's something that we can tune based on the cooling that's required. That's one of the roles that we play in GE licensing, is finding synergies between these technologies that initially are developed or invented to satisfy some GE business need, but we can translate those to similar demands in other markets outside of GE. That's where GE licensing steps in, make those connections.